And, tonight I'm going to be talking about something unheard of, something that actually very few people believe is even possible, and that is full stack integration testing that doesn't suck. At Futurist, we take testing very seriously, which means we write a lot of tests. And we also take a lot of care about our development experience. And if something doesn't feel right or is painful, we experiment with the tools, try this and that, and if there's nothing good out there, we end up writing our own stuff. And I think when it comes to integration testing web applications, we have arrived to a particularly sweet spot. And that's what this talk is about. But before we get into the details, let's quickly establish some base terminology in terms of what types of testing are there. Broadly speaking, there are unit tests and integration tests. Unit tests are focused on taking a unit of code, such as module or class, and run a test in isolation, testing its behavior in isolation, providing inputs and asserting outputs. Integration tests, in contrast, are treating your system as a whole, running tests across the entire stack. Those tests have their pros and cons. The good things about unit tests, they're easy to write. Since the code under test is very easy to set up, normally it's just, instantiating a class or importing a module or a function. They're very fast. They run in single process and incredibly fast to exercise, and have a good feedback. By which I mean, if anything goes wrong, it's typically easy to understand what has gone wrong, since there's just not much going on in a single test. The not so good things about unit tests are that they've got small coverage. So if you have a sufficiently large system, a single test doesn't cover much. It's not very interesting normally. Unit tests also don't cover the glue code, which is the code that is used to, put the units together. And again, in a system of any size, there's a lot of that code. And finally, the user interface is typically hard to unit test, because where the UI code runs in the context of this massive global API called DOM, and unless you're using particular frameworks such as React that sort of remedy that problem, it's kind of hard to have a unit. So there are integration tests to complement those bad things. So the good things about integration tests, they cover lots of code. A single test cuts through the entire system, all the layers, or lots of the layers, and that's why it's a valuable thing. It also covers glue code by definition, since it exercises everything, glue code included, and it covers the UI, since that's how users exercise our systems normally. Therefore, that's how integration tests exercise the system as well. And the not so good things about integration tests is that they're very complex to set up. Systems normally include databases and some session state and what have you. And to recreate a particular test in a particular place of an application, sometimes it can be just really hard. They are slow. They are slow to start and they are slow to run. They're slow to start because, again, applications consist of many layers, be it a browser application, and then there's a backend application, there's a database, and you have to bring it all up and run it synchronously-ish. And it's hard to debug. Because there's so many layers underneath just a browser window, and the browser is everything a test has to. Mostly, that's where the feedback is. For example, if somebody's booking a ticket and something went wrong, there is no confirmation ticket booked successfully. And then you have to go and figure what exactly happened. But all you have to start with is just a lack of a div in the browser. So yeah, we have unit tests. They're nice and easy. They're joy to work with, but sometimes not very useful. It's called good cop. And we have integration tests. They are tedious, slow, and painful. But try leaving those aside, those integration tests aside, and it's only a matter of time till you get into this. The slide is called "All unit tests are passing, no integration tests." Beautiful. So yeah, on a typical project, therefore, we have few integration tests because, well, you can't get away without having anything at all, but they're too painful to write lots of them. We have lots of unit tests to cover all the permutations underneath, and we have mixtures of the two in between, be it testing of some adapters, testing of queries, or maybe functional tests of particular components. Years ago, smart people already noticed that and came up with this notion of test pyramid, where we have UI, where we have expensive and slow tests at the top, and then some mixture of the slow and fast tests in between, and finally fat base of unit tests. But what if I told you that in JavaScript today, this isn't quite true anymore? The tests could be a lot less painful, and they could also be faster. So let's have a look again at the bad things of integration tests. We have complex setup. There's nothing much we can do about that here. We have slow and hard to debug. Those last two things are not inherent part of integration tests as such. They are at least partly implied by the tools we're using to write those tests. And the tools that are currently mainstream to write those tests in JavaScript and in many other web technologies is Webdriver, which in JavaScript is the Selenium bindings for node.js. And if that doesn't tell you much, it's okay. I still don't understand what that means to you. But I know what it does. And what it does is a very simple thing. It allows you to control the behavior of a web page, such as clicking buttons or watching things being on the page and not being on the page, from a remote process, for example, from a script. And that very neatly applies to the problem of integration testing, since we want an automated way of exercising the UI. So a typical WebDriver setup is running your backend application in one process. It's running your client-side JavaScript in another process, in a browser process. And it's also running tests in a third process. So we have, in a test, we have three of those processes all running together, coordinating the run. And that's where the slowness and the hard to debug bit come from. Because, for example, if we have a client-side application that is using CommonJS requires, then before it gets to the browser process, of course, we need to run through, for example, browserify, which is slow. And then if you want to debug, or if you want to pause the entire test, then you need to like 3 breakpoints. So you need to coordinate the breakpoints to pause tests in a particular place. It's just painful. And that brings us to the solution of this problem, and the solution is called Electron. And in a nutshell, Electron is a technology that allows us to, that gives an access to a DOM API and to the Node API in the same process. And what that means is that on line 1, you can create a div, and on line 2, you can create a file of the same script. Or on line 1, you can mount your React application, and on line 2, you can start your Express backend, and on line 3, you can seed your database. And that's exactly what I'm about to show you. Okay, so the test. We have a very simple app here. This app has a button, and when we click the button, it calls Express service and fetches to-dos. Here's the Ajax call that does that. And our test is going to do exactly that. It's going to click the button and assert that the data from the server, from the database actually, is showing on the page. Let's run it in, okay, the test is actually already finished, although you didn't see it. It was really fast, but we can run it again. And this is less than a second, and the test is doing exactly what I said. It mounts client-side application, it starts up the Express server, and it seeds the database as well, all within the same process and all very, very fast. Let's look at the test here and put some breakpoints and see how it steps through the code. Let's run the test again. And here, as you can see, we're about to click the button. And let's go and open up the browser application. And when it clicks the button, here where you have to trust me, it's going to end up here where it makes this request to the Express API to fetch the data. So let's carry on. Here we are. This is the browser application. And now let me show you something cool. Let me go into the actual server application, which is the Express endpoint, which is right where we query the database, the SQLite database, on the server, and we return the data. Here we are. Once again, this is the full stack, as full as you can get. And our entire test is paused, waiting patiently for us to examine, for example, the data we've just returned from the database. And then we can go here, and right before we show the data on the page, we can go back to our browser app. Here we are. We're about to show the same data. This is a browser app already, and the test is passed. So this is possible to do with Electron. And this test is written in Mocha, and there's an Electron Mocha library that allows us to run those tests in Electron. But also another crucial bit to this to the whole setup is the way to interact with the DOM, by which I mean the way to assert that certain things are on the DOM, they're in the DOM, and the way to click button, for example. And this is this is the library that we developed at Futurist, and we're using quite extensively for quite a long time already, called Browser Monkey. And it allows you to do exactly that. It allows you to assert the DOM and interact with the DOM. It looks like this here, which looks a little bit like jQuery if you really think about it, with one really important and critical difference. Browser Monkey has implicit weights embedded into it. For example, right after we click the button here on line 45, when we arrive on line 46, there is no data still on the web page. So if you were using jQuery, for example, this assertion would fail. There wouldn't be no 1 and 2 on the page. But BrowserMonkey knows that things in single-page applications don't always are there yet. So it's going to wait implicitly for stuff to appear. The reason it's fast is that there is no need to browserify or run your client-side code through the Webpack or something. Since Electron has the DOM API as well as has the Node API as well as DOM, we can just use our require statements and stuff just works. So it's really, really, really fast compared to Webdriver-based tests. In fact, I'm going to give you some numbers as to how fast it is. So it's always fast the second time, but under 3 seconds. And here we have 2 full stack tests that see the database, start the Express services, mount the app, and do everything, including cleanup and setting up. And that's pretty awesome, I think. And it doesn't stop there. For example, we can do something like running our tests in VDOM. It's not really Electron related, but it's just so cool. So I can't skip that. Look, it's 1 second. It's almost approaching those BDD threshold of 300 milliseconds being a perfect feedback time. Okay, not quite almost, but it's still good. Oh, okay, this is the demo. Right, so yeah. The test stack is, largely speaking, Electron Mocha and BrowserMonkey. So those 2 things put together allow us to write these otherwise historically painful tests in much more comfortable way. And it's not just a test. It's not just a test project on the side. We are using it for real on real client-side projects. We're running tests in Electron using Electron Mocha and BrowserMonkey too. So there's nothing that should stop anyone here to just go and do it tomorrow. And well, final note is that the fact that integration tests suddenly are easier to write doesn't mean that we should abandon all other types of tests. Unit tests are still a valuable thing for particular cases. For example, where you need to exercise permutations of a particular behavior or a logic. Well, this is it for me. Thank you. Yeah.
So on the client project where you said running like 1,000 or whatever tests, how much time does that take? How much time does that suite take?
Well, so we have a split there. We have tests that run only browser tests, mocking out the APIs. And this is a very large suite of tests, about 1,000 tests, and it runs in Electron Mocha. It takes about maybe 4 minutes, but obviously it very much depends on what types of tests they are. They're quite complex tests, not perfect. And we have proper full stack tests that run about 2 or 3 minutes. They're lesser than, they're about maybe 100. But there's more. They're not limited to just one Express app. They're like at least 5 or 6 of them, including some mocked services. So yeah, that's few minutes, which is quite good. But again, you'd have to go and see the particulars of the test to make some meaning of those numbers. Yeah. Yeah. Yeah.
Following on from Silver's question, stole my original one. Have you done any time or space complexity analysis on this? So like, how does it scale relative to doing integration tests in other ways that are tried and tested?
No, we haven't. Oh, sorry. Yes, repeat the questions. The question was, have we done any complexity analysis?
I'm just wondering how it scales relative to everything else, because I mean, obviously having 2 tests running in a second is pretty nice and impressive. When you've got the whole stack running on there, but when you have, say, I don't know, when you're actually scaling up to like real world kind of test suites, does this scale comparatively to existing tools and methods that we're using already, or is this like kind of nice but mileage may vary?
Well, those tests, the way we're running tests, we're running them sequentially, so one after another. So I suppose the way we're using it, it doesn't really matter if there's 1 or 1,000. It's just going to run one by one, and every test tears down completely everything and brings everything back up, mostly. So we haven't spotted any scalability issues so far.
I was just interested to see a graph going from like, I don't know, 1 test. Here's how long it took to up to like maybe 10,000 tests of a similar suite across several different integration test tools.
Okay, well, that's probably for the next version of this talk.
Maybe I'll gun you down on Twitter or something.
Yeah.
Nice one, cheers, man.
If kind of at the moment you have basically in Webdriver, I'm coming from the code driver because I'm actually a user. You have implicit ways you have actually everything execute on load, and then you can apply accelerate. What is the purpose of this? Right? Tool. Okay, this is working for Electron, right? Simulating the same stuff. But what's the purpose really?
The purpose of
Because you have everything built in the Webdriver tools at the moment. So what you said, the benefit you said, you basically get
the benefit is this. The benefit is the speed. The way Webdriver works fundamentally is different from the way you can run those tests in Electron. Webdriver has at least 3 separate processes, and which makes it slower and also harder to debug. For example, if you need to pause the test the way I showed, like in your Express app, you'd need to coordinate perhaps breakpoints, or you'd need to dance a little bit. But here you can just put a breakpoint and everything shuts there. And yeah, like I said, since there's no browser file involved or Webpack, there's no browser compilation at all. The startup time of those tests, which is important, if you carry on repeating tests time after time while you're working on a feature, it's really important that it starts up quickly. And I think it's a very impressive gain there. So those are the things. When I was talking about Browser Monkey and implicit weights and stuff, yes, in a way it mirrors what Webdriver is giving you as a similar API for sorting and manipulating or interacting with the page. But since we're not using Webdriver because of its disadvantages that we don't really like, we had to come up with a similar tool that allows us to interact with the page and query it down. Okay.
How do you manage different browsers?
This is a very good question. This is one area where this approach falls short. Of course, you can't manage multiple browsers. Or at least I don't know how to do that. Maybe you can. But I suppose the argument here would be that largely we're interested in exercising behavior, and therefore, if we want to test the browser code on different browsers, we just end up with a different suite of particular tests that test that slice of our stack and nothing else. So that would be my excuse. Thank you very much.